Hello everyone, this is a demonstration of the Dolphin therapy activity, which involves the randomization test with a categorical attribute. So the first thing I'll do is plot the observed data. The improvement will go on the x-axis because it's the response variable, and the condition will go on the y-axis because it's the treatment variable. And we'll get the percentages of each. Notice that 67% of the Dolphin patients improved and 20% of the control improved. So the observed difference is going to be 67 minus 20%, which is 47%. So we'll keep that 47% in mind later on. So now we will start the randomization test. And so I'm just going to minimize this for a minute. We'll get a sampler. We're going to take out the things that are in the mixer, and we'll put in a counter. And remember that the response is what goes in the counter because we're listing all the responses. So you'll take the improvement, right-click and copy, then click on this gray area, and we edit paste cases. And we're going to call this attribute the improvement. And then that will just list all of our improvements, whether they improved or not. So then we will take stacks just to the right of it. We'll add these two, and we'll call one control and one dolphin. It doesn't matter which order you do it in, because both are in there. And we'll call this the condition. And so we're going to show the counts, and we have 15 in the control group, 15 in the dolphin. And since we have 30 total people, we repeat 30 times and move this to fastest. And also make sure you do without replacement because we want to make sure that there are only 15 control, 15 dolphin, just like in the original study. So this is without replacement. So now we'll run this. And we're going to plot the data much like I plotted the observed data with the improvement on the x-axis, the condition on the y-axis, and we get these percentages. And so what we're going to do is we're going to collect the difference in percentages between dolphin and control. So I right-click on the percent of the dolphin group who improved and collect statistic. I right-click on the percentage in the control who improved and collect the statistic. And then we want to do this many times, but first we have to do the difference. So we will edit this formula to compute the difference. And since with the observed data I did dolphin minus control, that's what I'm going to do here. So I double click on this percentage dolphin improvement minus the percentage condition control improvement. And I want to repeat this many times. I'm going to turn off the animation to speed things up. So minimize everything. And go back to this plot and this history of results table. We go to Object, Inspect Collection, and uncheck animation. We'll do this 99 times here. And each time it's collecting the difference. So I'm going to plot this. We stack. And then we use the divider tool to get the percentage of results that were as extreme or more extreme than our observed result. And since our observed result was 47, I'm going to expand this so that the axis ends at, let's say, 60 or something. Use our divider tool. And the observed statistic was 47% difference. So that's somewhere around here. Notice that there's the divider on the left bottom corner. It shows you where the divider tool is. And then we get the percentage, which obviously here is 0. So our p-value is very, very small here. We have very strong evidence against the null model of no difference. So this supports the conclusion that it's likely that this difference did not happen by chance. And so it supports the idea that the dolphin therapy did help. And since we do have random assignment here, this leads us to conclude that dolphin therapy is beneficial to patients who are suffering from depression.